Okay, today we're going to do a little bit of reviewing of right triangles. The first thing I need to talk about in this section, which is a little different from what we have been talking about, is an exact value. When we take the square root of something, if it doesn't have a square root, so like the square root of 4 is 2, that has a perfect square root, right? A whole number square root. If it doesn't have a whole number square root, we get a decimal, and that decimal continues to go on and on and on and on. It's actually called an irrational number. It just keeps going. And what your calculator actually does is your calculator just rounds it probably to the 10th place or the 9th place, depending on how far it goes out. All right. So when we're talking about an exact answer, we want to go ahead and leave our answer without a decimal. We want to go ahead and leave it within a radical, within the square root symbol. All right. We don't want a decimal. So I want to do a little bit of reviewing here. You guys had this probably in algebra. And I just want to do a little bit of reviewing of how you simplify a square root without using your calculator too much. I mean, you can still use a calculator, but we don't want a decimal. All right. So what I'm going to show you, I'm going to show you two ways. I like my way. I'm going to show you my way first. What I like to look at is there a perfect square that I can take into the square root of 50? I'm looking at this problem here. What perfect square can I pick that goes into 50 evenly? By perfect square, I mean 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. What I'm saying, a perfect square is it has a square root that has a whole number. So 5 times 5 is 25. 6 times 6 is 36. 25 is a perfect square. 36 is a perfect square. 49 is a perfect square. 8 times 8 is 64, and so on. All right. So what I'm looking at is I want to figure out, is there a perfect square that I can that goes into 50 evenly? Well, if we think about it, well, 4 doesn't go into it. 9 doesn't go into it. 16 doesn't go into it, but 25 does. I can take 25 times 2. So the thing about radicals, as long as two numbers are both in a radical, we can multiply them. So I can multiply the square root of 2 times the square root of 25 is the square root of 50. You can check that yourself on your calculator. You're going to get the same thing. All right. So, like, if you type in your calculator, type in square root of 50, you'll get some decimal. And then if you type in the square root of 2 times the square root of 25, you're going to get that exact same decimal. All right? But we know what the square root of 25 is. We know the square root of 25 is 5. All right? So we can change this to 5. So I have 5 times the square root of 2. 2 is not a perfect square. I can't take anything times itself to get 2. So I'm just going to leave it like that. So that's simplifying. That's an exact answer right there. No decimals. All right, we leave what we can't simplify in the radical. All right, so the same thing, let's think about 80. Well, first thing that comes to my mind is I check 4 for 80, because I know that I can go into it 20 times, right? So I have the square root of 4 times the square root of 20 would equal the square root of 80, right? Well, we know what the square root of 4 is. That's 2. Well, we got to stop and think a little bit. Is there a perfect square that can still go into 20? Well, I know 4 goes into 20, so this one can actually break down yet. So we still keep our 2. So 2 times the square root of 4 times the square root of 5. All right, well, we know what the square root of 4 is. That's 2, so 4 times the square root of 5. And if you look back, actually, 16 goes into 80 5 times. 16 times 5 is 80. I could have picked 16 right off the bat right here, and I wouldn't have had to do that extra step. We just got to make sure we check ourselves that we can't simplify this radical anymore. In this case, we had to. We could, so we had to break it down a little farther. Okay? And how I got this 4 out front, you know, 2 times, well, the square root of 4 was 2 times the square root of 5. I'm not sure if I made that too clear. Okay? Let's think about 48. 4 can go into it, but I think there's a bigger one. What about 16? I think actually 16 times 3. The square root of 16 times the square root of 3, I believe. Yeah, that goes into it. All right, 16 times 3 is 48. Well, we know what the square root of 16 is, and that's 4 times the square root of 3. It doesn't matter. If you pick 4, it would have been the same thing. You would just had to keep simplifying. You had to do one more step. Last one, D here. If you think about 119, I can't think any number times itself equals 119 at all. I can't even figure out. I believe 119 is a prime number. If you have a square root of a prime number, you don't have to do a thing. All right, that's simplified enough. So your answer actually is just the square root of 119. And on your calculator, here's how I say you can use your calculator, but you can figure out, hey, does 4 go into 119? No. Does 5, or, does 9? No. Does 16? No. You can go and check all that stuff out. Check all the perfect squares. When you find a perfect square that goes into that number, you can go ahead and use that to simplify that radical. The other way you can do it, and I'll just show you one example. The other way you can do it is, and maybe this is the way you were taught, but we can break down 50 into a product of primes. All right. So we can break down 50 into 2 times 25, right? And we can still choose prime. And we can break down 25 into 5 times 5. So we have 2 times 5 times 5 all underneath the radical. All right. And what this 5 times 5 is if there's 2 of them, we can bring it to the outside. So since there's 2 of them, I can bring that 5 to the outside. There's only 1, 2, so I have to leave it inside. That's maybe the way you were taught. I don't know. It's pretty much the same thing. But if you remember how to break a number down into the product of primes, you can certainly do that method as well. You just need to have 2 on the inside to bring it to the outside. Okay? And why that is because that 5 times 5 is the same thing as 5 squared. Well, the square root of something squared is just the number itself. So that's why you just bring a 5 outside and not 2 5s. Okay? And that's why you need 2 5s in order to bring it outside. Okay. Moving on. So here's our review of right triangles. You remember the Pythagorean theorem? Where a squared plus b squared equals c squared, where a and b are the 2 sides of a right triangle, and c is the hypotenuse of a right triangle. And remember, the hypotenuse is always opposite of the 90-degree angle. All right? So in order to solve this, all right, the hypotenuse is always opposite the 90-degree angle, so we know x is going to be our c here. So we're going to have 8 squared plus 15 squared equals x squared. And that's pretty simple. We can just type that into our calculator and figure that out real fast. So 8 squared plus 15 squared, and we get 289. Well, okay. So we get 289 equals x squared. Well, first of all, let's check to see if 289 has a square root. Okay, so we can just hit the square root button and bring this down. Well, it actually has a perfect square. So, hey, that's perfect. We don't have to do any simplifying at all. So the square root of 289 is 17. So x equals 17. That's pretty easy one. That's a nice little review of the Pythagorean theorem. What about down here? Okay. All right. Remember, the hypotenuse is opposite of the 90-degree angle. All right. So I'm going to have 5 squared plus x squared equals 12 squared. Well, 5 squared is 25. And 12 squared is 144. To get x by itself, I need to subtract 25. So subtract 25. I got to borrow here. All right. So I get 9, 1, 119. So I have x squared equals 119. So x equals the square root of 119. Well, we talked about this earlier. Is the square root of 119 is not a perfect square, and I don't think a perfect square goes into 119. So we can check it ourselves. We can say the square root of 119. See how that's a decimal and it keeps going out? My calculator rounds out to about the 10th spot. All right, we don't want that. We want the exact answer. Okay, so we can check. Well, 119 divided by 9. Does that go into it? No. 119 divided by 16. And we can check all the perfect squares. I'm going to tell you right now that none of them are going to go into it. All right, it's actually 119 is a prime number, so we're not going to find any perfect squares that go into it at all. All right, so our answer is just x equals the square root of 119. All right, what about a problem like this? We have an isosceles triangle. Notice that these 2 sides are congruent to each other. We have an isosceles triangle, so we should know something about an isosceles triangle. When this comes down, when an altitude or the height comes down and intersects at the base, we know it actually splits it in half. So x automatically equals 8. And in order to solve this, we just can do the Pythagorean theorem. We have a right triangle right here. All right. So we can say, all right, well, 8 squared plus y squared equals 17 squared. 8 squared is 64 plus y squared equals 17 squared was, I believe that was 289. We had that earlier. 289, I can subtract 64. So we have y squared equals, we'll subtract 64 here. And we get 225. y squared equals 225. So y equals the square root of 225. And we can check out ourselves. Is that a perfect square? All right, 225. So we can hit the square root. 225. And actually it does. 15 squared equals 225. So y equals 15. So x equals 8 and y equals 15. I think that's all I have for you. There's your assignment. I think it'll also be on the email that I'm going to send you. Have a good day in class today, and we'll see you later.